Welcome to the second video in our series, Calculating College Access. In our intro video, we talked about how categorizing your students into a few different subgroups based on their academic qualifications is a fundamental part of implementing a Tier 2 college counseling system. In this video, we're going to dig into how you actually do that. We'll start with a little thought experiment. Imagine you are sitting down for an advising session with a senior from your school. This student has an unweighted GPA of 2.6 through their first 3 years of high school, a little better than half B's and half C's, and an ACT score of 19, or about 1,000 SAT score if you're more comfortable with that. The student tells you they are planning to apply to 3 different colleges. The first is your local community college. The second is the flagship campus of your state's university system. The third is a prestigious Ivy League university. I'm guessing that without knowing anything else about the student except what I've told you, their grades and their test scores, you probably have a pretty good idea of whether the student will be accepted or denied by each of these 3 colleges. Depending on where you live, maybe the state university is a bit of a close call, but if you're an experienced school counselor, you probably have a pretty good idea about that one too. Now let's imagine that the student applies to some additional colleges. Think of some other institutions you're familiar with. Let's say one of them's a for-profit college that offers a lot of industry-specific majors and a mix of 2- and 4-year programs. How about one of the smaller and lesser-known 4-year colleges in your state university system? Bet you have a pretty good idea of the student's chances of getting admitted to those schools as well. The purpose of this thought experiment is just to illustrate that a student's cumulative grades and standardized test scores are really strong indicators of their chances of being admitted to all kinds of colleges. Of course, personal statements, application essays, recommendations, strength of schedule, these can all play a role, even a decisive role, in any single application. But just these 2 numbers of GPA and standardized test score very often contain enough information to make accurate predictions. These scatter plots show some actual acceptance patterns from different colleges. The red points are students who were denied admission, and the green points are students who were accepted. You can see that for the most part, the acceptances are clustered together in one part of the graph, and the denials are clustered together in a different part of the graph. This suggests that for everything else involved in the application process, these 2 numbers are very indicative of admission results a lot of the time. In Chicago, a team of researchers looked at application outcomes for Chicago Public Schools seniors and used this insight about grades and test scores to produce this framework for college access. By setting a few cut points in both the GPA and the test scores, they divided the possible combinations into these squares. The different color-coded levels inside the squares correspond to the college selectivity ratings used by the publisher Barron's in their Profiles of American Colleges. These access levels also represent the most selective type of college where students in that range stand a good chance of being admitted. We call these match colleges for the student. Now, because the research behind this framework is entirely based on applications by Chicago Public Schools students, these exact predictions shouldn't be adopted outright in another state or district context without scrutiny or validating its predictions against your own data. But the merits of this basic approach to monitor applications and prevent students from systematically engaging in college searches that don't meet their academic potential is something that's worthwhile to do in any context. Now that you've seen the framework itself and a little bit about how the kinds of predictions it makes, let's turn towards the technical side of how you assign a large roster of students to appropriate access groups. Okay, we're getting into the technical part of calculating college access. For sake of this demonstration, I am going to use the research-based framework established here in Chicago, although I'll reiterate, focus more on the process of using these 2 variables of GPA and standardized test score And don't necessarily assume that these predictions will be valid in your district or state context unless you've validated them first. Also, you'll just see that I am working in a standard spreadsheet program. Everything we're going to model here can be done in Excel. I happen to be working in Google Sheets, which I like for a few reasons, but there's nothing specific to that platform that's going to limit your ability to use these formulas, these same formulas, in another spreadsheet program. So what I have in front of me and what I'm going to be working from is really just a roster of students. This is anonymous student data, not real names or numbers. But you're seeing that really all the information I have for them is the student's name and ID number, those directory identifier pieces of data, and then the two variables that I'm going to derive my college access subgroups from, GPA and ACT. You see I have a blank column here that could be populated with SAT scores, and I could use the same strategies I'm going to use in writing my formulas based on SAT scores, but I happen to be working with some fake data that has ACT as the standardized test. And you can see that I've left a column blank, and that's the column that we want to populate with these categories. Again, not every individual cell, but our 5 different levels that you see here of somewhat selective, non-selective, very selective, 2-year. And so obviously one way that I could go about populating this column is just manually. If I start on my top row, I have a student with a GPA of 2.2, ACT of 19, and I could simply look at the grid and find those coordinates where the student would fall. They would be in this range of ACT from 18 to 20. Their GPA would be between 2 and 2.4. And so the student's college access category would be in this somewhat selective range. So obviously, just student by student, I could look up where they fall on that grid and type in the name of the access group that they would fall into. Obviously, for a long list of students, and the longer your list of students is, the more tedious this will become. I'm not working with a particularly long roster, but it's almost 200 students, and that would be pretty tedious of a job to type this in. Especially when we start to deal with applications data, where that data can scale up. You might run the report one week and see 5 applications for one student. You might run it the next week and see 7. So especially with a data set like applications, as opposed to the simple roster where it can scale up, I really want to get out of the business of looking up these access groups manually and start to do it by some kind of formula that'll do that basic logic work for me of looking up where the student falls on the grid and automate that. So I've tipped my hand a little bit. I'm going to be using some functions which are called logic functions that are pretty common to spreadsheet programs. And I'm going to build this formula out bit by bit. What we're going to end up with is a pretty long and elaborate formula, but what it's going to do is populate this column, as I've started to do, with the college access level for the student. So let's move on to the second one and begin to do this with some formula work. So the second student on my list has a GPA of 3.72 and an ACT of 24. So if I cheat a little bit and go over to the access grid, this is a student that would fall in this bottom right box in the very selective subgroup. But let's get into how you do that with logic as opposed to typing in that category. So the first part of a logic formula that I'll introduce, and just to open any kind of formula or function in the spreadsheet program, the first thing I'm going to type inside the cell is an equal sign. But let's start with just the very basic functions of a logic formula. If I feed after this equal sign any kind of statement that the computer can test as either true or false, it'll recognize that I'm giving it a logic formula, and it'll start to return a value of either true or false after it's tested my statement. So just to model this really quickly, I can say begin my function. I'll refer to the student's GPA with the cell reference of C3, and I'll begin a logical statement by using an equal sign or a greater than sign. So I'll just say C3, which is the student's GPA, is equal to 4, and hit enter and let it resolve that logic test. Now it's returned false because I've said that a cell that's actually equal to 3.72 is equal to 4. That's obviously not a true statement, so it's returned false. If I modify this a little bit, instead of saying the student's GPA is equal to 4, what if I say the student's GPA is greater than, instead of a 4, I'll give it a 3.5. All of a sudden I've changed the logical test I'm asking the computer to do, and I've also changed the result or the answer to that. It's now a true statement. 3.72 is greater than 3.5. So by pairing together these logic statements, I can test the student's academic qualifications to see whether they fall in the right boundary. So obviously I've tested GPA, but actually to be in the very selective subgroup requires a couple different tests. I need to test that the student's GPA falls in a particular range, but I also need to test that their standardized test score falls in a particular range. In this case, 24 or higher. So here I'm going to expand on my logical statement, and there's a function I can use to do multi-part logical tests. That function is called AND. So instead of just starting with my logical statement right away, I'm going to begin my function and then say and that means I'm going to give more than one logical statement, and you can offset those by commas. And so then what the program's going to do is test each of those statements, and because I've used the word and, it's going to require all of them to be true, and if all of those logical tests are true, then it's going to return the value of true. So I've got my statement for the student's GPA is greater than or equal to 3.5. I'm also going to test that the student's ACT score, which is in cell D3, is greater than or equal to 24. I'm even going to give it a third part. I'm going to set an upper limit on the GPA. So this AND function is going to treat each of these as a separate logical proposition. The student's GPA is greater than 3.5. I'll make that greater than or equal to. The student's GPA is less than 4, so that's my way of saying, is the student's GPA within that range of 3.5 to 4? And then my third logical proposition is the student's ACT score is greater than or equal to 24. Now these should all evaluate to true, so I should continue to get true inside my box. Okay. So you can see we're getting closer, but if I go back to my access grid, there's one way that the student can be very selective, and that's how I've written my statement so far. There's actually a whole separate box inside this grid where the student can also be very selective. So far I've written my logical statements to test whether this most bottom right corner of the grid is where the student can be found. I also need to write a second one to see whether they fall here. Now, in order to do that, I'm actually going to wrap another logical test around everything that I've written so far. So remember, my AND function tells my program I'm going to give it a multi-part logical test. And if all those conditions are met, then resolve that to true. There's an alternative statement called OR, and that's also set up to take multi-part logical tests, but it's a little bit more permissive. If any one of those conditions are met, then it will resolve to true. So in this case, my OR statement is going to take as its first test, because the AND is inside of it, it's going to use that entire multi-part definition as its first logical test. The second logical test, I'm going to write another AND statement that fits the criteria of this second very selective tile on the grid. And so that second part is going to be the student's GPA, again, cell C3, is greater than or equal to not 3.5 this time, but just 3.0. And it's also less than or equal to 3.5, because that's where the boundary between those two tiles on the grid are. And the ACT part of the statement is going to continue to be the same. They still have to be at or above a 24. So this first AND function tests whether the student falls in that one very selective tile. The other AND function tests whether the student belongs in the second very selective tile. And because the OR is wrapped all around it, it says if the student can be found in either of those, then it's true that they're very selective. So I'm going to finish that function, and I did get true. Now you're seeing that in my first row of data that I populated manually, I actually typed in the category. Here I've got my logic working right, but instead of giving me that category name of very selective, I just have that true. And I don't want a bunch of true false flags. That's not as elegant to read as knowing what the student's access group is. So in order to control the value that actually shows up here, I'm going to introduce one more logical formula that's going to be bundled in with the rest we've used so far. And I'm going to wrap it around this entire function we've written up to this point. That function is called if. Now the way if works is the if function starts with a logical test. You give the program a logical test. It evaluates that logical test. And if it finds the result is true, then you can feed it a value of your choice. And then if the whole set of tests resolves to false, you also give it a choice for what to display in that case. So I've started my if function. This entire compound of or and is my logical test. So it's performing all those logical tests we've written up to this point to see whether the student is located in one of those very selective tiles. Then after that, I'm going to type a comma, and then I can, as my second part of the if function, I'm going to say what's the value to display if all that logic is true. And here is where I want the actual name of the access subgroup. I'm going to put that inside of double quotes. And then if it's false, I'll just program it for now to leave the column blank, leave the cell blank. And I'm going to do that with just a pair of double quotes with nothing inside them, right next to each other. So that's the equivalent of saying leave it blank. So far my function's working this way. If any one of these multi-part logical tests are true, that's kind of how I'm translating the if, or, and compound. If any one of these multi-part logical tests is true, and then code the student very selective. If any part of my logical test is false, then leave the cell blank. And so let's actually complete that formula. And you can see that it is working so far. It's correctly identified the student as very selective. If I copy that formula all the way down my roster, what you're going to see is that it leaves a lot of the cells blank. The majority of the students are not in the very selective subgroup. But you can see that it is doing a good job of detecting when it gets to a student that is in that very selective subgroup. You can see that my cell is beginning to be populated correctly. So we're on the right track, but we're still missing one piece here, which is that when it encounters a student who's not in that tippy-top selectivity subgroup, it isn't coding their subgroup. So here, the way I'm going to solve that is go back to my function. Remember, what was the last thing I did? I feed it the logical test. I say what to put in the cell if it's true. And now, instead of what to do if it's false, instead of using those double quotes to say leave the cell blank, I can actually begin a whole new chain of logical tests. And I'm going to do that by opening another if function. Opening another if function. And then I can build, again, the same way I showed from the inside out, I can build a new set of logical tests to see if the student falls in the next most selective subgroup, and then chain my logic together. So I'm actually going to unhide a column where I already have this done. And you can see that the logic formula ends up being a longer chain of logical tests that all involve those if, or, and functions. And the parameters are matching the GPA and ACT values that represent the borders between those tiles in the grid. But by combining those, I've coded an entire column that's going to correctly categorize each student on my roster to their appropriate college selectivity subgroup. We'll continue this demonstration when we start to work with applications data, and you'll see how we can begin to scale it up to look at actual applications in real time pretty quickly.